Hello students, this is Manjunath Pujar. Today I am here to give you the idea about the second database assignment, that is order database. According to the syllabus, the second lab assignment is about order database. As the name itself says, this is about placing of an order to the particular company, and they have taken the part of that and introduced the three different tables. When we look at the three tables, we are having the first table as the salesman, second table as the customer, third table as the orders. And this is basically consisting of only the three tables. Now we will have a look at the columns in this particular table. The salesman, this table maintains the information about the salesman like salesman ID, name, city, commission. Again, with respect to the customer, we are having the customer ID, customer name, city, grade of that customer, followed by salesman ID. Again, coming to the orders table, we're having order number, purchase amount, order date, which customer, which salesman. When we look at the table names followed by the column names, our first job is to understand the scenario of this particular assignment. In order to understand the scenario of any assignment, first we need to clearly understand the primary key and foreign keys in this particular table. The salesman, when we look at the salesman, every salesman is having the unique identification with the salesman ID. That's why it is the primary key. Again, when it comes to the customer, every customer is uniquely identified with the customer ID. That's why this customer ID is the primary key. Followed by orders is the order number is the primary key. Again, when we look at the other columns in this particular table, salesman, in that we do not have any foreign key. But when it comes to the customer, we are having the salesman ID as one column, which indicates it is the foreign key which is referring the salesman. Again, when it comes to the orders table, we are having the customer ID as well as the salesman ID. That's why these two are again the foreign keys which are referring salesman as is the customer. Now we need to understand what are the relationship between among these particular tables. To get an idea about that particular case, so as usual, we are supposed to understand the ER diagram, entity relationship diagram. When we look at these all three tables, as all three tables are having basically the primary keys, then that means these all tables in entity relationship diagram are going to act like a entities. Now let us have a look at ER diagram of this particular case. Again, coming to the ER diagram. In the ER diagram, as I told you, salesman, customer, and orders, all three tables are going to act like an entity. And when it comes to the entity, every entity is associated with the attributes which are described over here: salesman ID, name, city, commission. As salesman ID is the key attribute, that's why it is underlined. Again, coming to the customer, customer is also having the customer ID, customer name, city, and grade. And here the customer ID is the primary key. And orders, in that we are having order number, purchase amount, and order date. In that order number is the key attribute, that is the primary key. All key attributes are underlined. This one we need to concentrate every time when we try to draw the ER diagram. Now coming to the part of the foreign keys, as I always used to say, the foreign keys are not going to be represented in the ER diagram. Foreign keys are nothing but the relationship or association between the two or more entities. Here, when we look at the table, we are having in the customer table, that is the salesman ID is the foreign key. Then when we say the salesman ID is the foreign key in the customer, then what kind of the relationship between the customer and salesman? Here they had indicated the kind of relationship among the entities. Salesman and customer, these two entities are related with the relationship sell to. Customer and orders, these two entities are related to with the help of received from. And again, salesman and orders are related with the relationship takes. Now let us understand the meaning of these relationship. What kind of the meaning these relationship are actually trying to give. As I always used to say, relationship, it is nothing but an association between two or more entities which are basically established to get the new information. What kind of the new information we're able to get it? Just we will have a look at this particular case. As this is the case of orders database. Normally what happens, the company is there, in that the customer is going to place the order, and those all orders are received from the customer. Once the orders are received from the customer, those orders are given it to the salesman, and this particular salesman are going to sell those all orders with respect to products are sold to the customer. This is the case over here. Now we will understand here the cardinality ratio among these particular the scenario. So now first we will start with the customer. One customer can place many orders. Normally, this is the case in a real time situation also. When we are trying to purchase any products from the Flipkart or Amazon, one customer can place obviously more than one order. This is the case. One customer he can place many orders. But when it comes to the from the order side, one order is actually placed from the one customer only. That means a single order cannot be placed by more than one customer. That is the real world scenario. That's why, because of that particular real world case, we used to say the cardinality ratio between these two is 1 is to n from the customer to the order. One customer can place many orders, but one order is received from only one customer. It is not from the more than one customer. This is the case between customer and orders. Once the orders have been received, next job at the company level is those orders need to be assigned to the salesman so that he can sell it to the customer. That means here a one salesman he can take more than one order. Obviously that is the case. Okay, so if one particular salesman is there, if he's trying to sell more than one products, obviously the number of orders are going to be also more than one. That's why one salesman he can take more than one order. When we are trying to read out or establish the relationship, one salesman he can take more than one order. But when it comes to the from orders to the salesman, we can say one order is given only to the one salesman. That means if I want to purchase like a mobile phone, say for example Redmi, that time that order is given to only one salesman. The same mobile phone it cannot be sold by more than one salesman. That is the real world case. Because of that, here also a single order that is given to only one salesman. From the orders to salesman, it is 1 is to 1 cardinal ratio. From salesman to the orders, it is one salesman he can take more than one order. Now, when it comes to the salesman, once he receives the order, according to the order, and he's going to sell those all products to the respective customer. That means he can sell he can sell the orders to the many customer. One salesman he can sell it to the many customer, because as he has received more than one order from the company, that time one salesman he can sell it to the many customer. Again, when it comes to the customer side, one customer he can receive the product from only one salesman. That means one product is received from only one salesman, not from the more than one salesman. This is what the case. And by looking at these all scenarios, this is what ER diagram has been drawn. And as I always used to say, here already the table structures had been given. According to the table structures only we are supposed to put this particular ER diagram. But in reality, first we need to draw ER diagram, then we need to go for the mapping of tables. Okay, so now by looking at the table structures, by understanding that particular situation, then here we understood what is the actual case of this particular order database. So once we get to know, in simple words, you just understand customer, he can place the order. That means company can receive orders from the customer. Then once the orders have been received by the received by the company from the customers, then those all orders are given to the respective salesman. Then later salesman he can sell those all the orders. According to the orders, he is going to sell the products with respect to that order to the customer. This is what the simple case, and for that simple case we are supposed to maintain the data. Now after that, once we get to know the basic idea about ER diagram, our next job is to go with assignment. According to the assignment, what questions they had asked. As usual, our first job is to create these three tables by properly specifying the primary key and foreign keys. So now I already highlighted which are the primary keys and foreign keys. Now let us start the creation of the tables followed by inserting records into the table. So before inserting the records into the table, we need to look into the requirements of this particular queries. Here the question is count the customers with the grades above Bangalore's average. That means while entering the records into the table, we need to take into the consideration of Bangalore. When they are clearly asked, that time we need to go with that particular case. After that, in remaining all queries, they have not specified any specific one, but at the last, demonstrate how you demonstrate the delete operation by removing the salesman with ID 1000. That means here it also says we need to give the salesman ID with 1000, 2000, like that. So when we look at this all the questions they had asked, according to that we need to create the tables, we need to insert the records into the table. So now let us start inserting the records into the table. So now we'll start with first step, that's the creation of the table. So in the creation of the table, our first job is to create the table. So now let me open that particular MySQL command prompt. This is the MySQL command prompt. Our job is to first, as this is a database, that is order database, we need to create first a database by the name order database. Create database, order database. Okay, so once the database has been created, our next job is to use this particular database, so that we can create all the tables. So now I have created the order database table, then I have used that table for my creation of upcoming tables. Now I will start with the first table, salesman. In the salesman, totally 4 columns are there. So for to save the time, I'm just copy and paste that particular tables. Okay, so now I have created the table salesman with the salesman ID as the primary key, and salesman is having name, city, followed by the commission of that particular salesman. Now first table has been created. Our next table is customer table. Customer table. Let me create the customer table. Okay, so in the customer table, so we will have the customer ID as the primary key, then we are having customer name, city, grade, and here the salesman ID. Salesman ID is actually the foreign key which is referring the salesman table in that salesman ID. So here in the previous assignment we have seen on delete cascade, here a little bit change on delete set null. So we will see what exactly this particular constraint does while deleting the records from the table. So in the previous case we had worked with on delete cascade. Today we will see on delete set null also. Okay, so now third table is about orders table. So now we will create orders table. Okay, so now in the orders table, again order number is the primary key, so purchase amount, order date, the customer ID and salesman ID, these two are the foreign keys which are referring the customer table as well as the salesman table. So here we had mentioned those tables reference. Here I have mentioned on delete cascade. So in this assignment we are going to see the on delete cascade as well as the on delete set null. These two the constants, additional constant we are going to impose. So now we have created the three tables successfully. Here one more point I want to highlight. Here I am, while creating the table, I am using orders, not just order. Why? Because we are having already a keyword by the name order by clause. So because of that, it is not possible to create the table with the name order. So that's why we need to mention orders here. Most of the students will make a mistake while creating the table. They just give the order. It is not possible to create the table with order because order is the keyword in this particular SQL. That's why. So focus on this particular orders. Okay, so now we will enter the records, insert the records into the table. So now I will insert records in all three tables at one stage to save the time. So I'm inserting the records in all the tables. Now I'm inserting all the records. Okay. So now I have inserted the records in all three tables. Let me show you what kind of the records I had inserted in these all tables. First table is the salesman. Okay, so in the salesman, we are having the details like salesman ID. So salesman ID starts with 1000. We are having the five salesmen's information: John, Ravi, Kumar, Smith, Harsha, followed by the respective cities and their commission once they sell the products to the respective customers. So this is the salesman table. Now let us see the second table, that is the customer. Okay, so in the customer table, so we'll see in the customer table again we're having the five customers information, and these are the customer details like Preeti, Vivek, Bhaskar, Chetan and Mamata, and the respective cities. And every customer is having the grade. Here the two or more customers can have the same grade. In our table we are having 400 and 400. Okay, so this is the grade given to the two customers, 12 as well as the 14. Okay, so now again we are having the different grades: 100, 300, 200, followed by the 400. And again we are having the information like the salesman ID, that's the 1000, that indicates that this is the salesperson or salesman. He sells the products to the two customers, that is 10 as well as the 11. And again the salesman with the ID 2000, again he also sells the products to the two customers like 12 and 13. And the third salesman, that's the 3000, he sells the products to the 14, that is the Mamta. So that means this is what the meaning you are supposed to understand. One salesman, he can sell the products to the customers, and the second salesman also sells the products to the two customers, and third salesman, he sells product to only one customer. This is the second table structure. And the third table is orders table. Now we will see in the orders table what kind of the information is there. Now coming to the orders table, here totally 6 orders are there, and the order amount for the each order, then respective order date, that means when the orders have been placed, and who are all the customer with ID 10, he is the one customer. He placed the two orders with amount 5000 as was a 450 on the respective date 4th as was a 17. And for this customer, the salesman 1000, he sell the products to this particular customer, that is the 10. This is what the case. Again coming back to the next salesman ID with the 2000, he sells the products to the customer ID 13, and this is the order amount like that. This is the way how we are expected to understand the table structure followed by the content in this particular table. Now first job has been completed. We have created the tables, followed by we have inserted the records into the table according to the questions what they used to ask. Now we will see what are the possible question they used to ask with respect to these queries. Now we will see the question over here is count the customers with the grades above Bangalore's average. That means we need to count the customers with the grades, and those customers should have their grades above the Bangalore's average. That means we need to understand first average of a particular city, that is Bangalore. Now we will have a look at the query. Okay, so as I told you, first we need to know. Okay, so here we are having the customer table. Just look at the customer table. In the customer table we are having the customer ID, name, city, grade as well as the salesman ID. So now with respect to the Bangalore, that is Bangalore, totally the three records are there. Okay, and these three records, that means these three customers, Preeti, Chetan and Mamata, and their grades are 100 and 200 and 400. So 100 plus 200 plus 400, totally 700 divided by 3. So whatever the value we are able to get, see, let us we execute the part of the query so that you can understand. I will show you. Okay, so here I am just executing this query. This query is about select average grade from a customer where city equal to Bangalore, because we need to display those customers whose grade value should be greater than this average grade value of a particular city, that is the Bangalore. So here this query actually displays the average grade of a Bangalore city. Average grade of the Bangalore city is what? 233.333. Now when we look at this in the Mangalore, Chennai, so many customers are there. So we need to display those customers whose grade value is greater than this average value. Okay, so now again coming back to this customer, just look, have a look at this. This grade value is 100, that means this record we should not display. Again, when it comes to the 300, okay, we need to display this record, and we need to display 12th record, and again we need to display this record. That means according to our requirement, so we do not need 100 and as well as the 200, because it is not above the average grade, that is 233. So now according to that, again the query here we have written, have a look at this. Again I am going to show you the part of the query, okay, so that you can understand. So now we will display, now again we will display, I am showing just part by part query so that you people can understand properly. Okay, so now here I am displaying grade. Okay, so and the count of the customer of that particular grade. Okay, so now let us display, now let us display okay, so here the question, first you understand question is count the customers. We need to count the customers with the grades. That means in the output we are supposed to display grade as well as the count of the customers of that particular grade, and the condition is those customers with grades should value should be greater than Bangalore's average. That's why first here I am displaying, generally here we do not have any condition, grade with count of the customer, 100, 200, 300, 400. That means all customers with grades have been displayed, because only four grades are there: 100, 200, 300, 400, 1, 1, 1, 2. So because, so for the 100 only one customer, for 200 only one customer, for 300 again one customer, for 400 two customers. Like that only we have got the count. Now here the condition has not applied yet, so for this we are applying the condition. Once the condition has been applied, so the, as I told you, so totally we are supposed to display the records with this condition. As I told you, as I told you, the grade 300, okay, so the count is only 1, and grade 400 count is 2. So according to that only we got the output 300 and 400, because 300 value is greater than the average value, that is 233.33, and 400 is also the grade value which is above this average. And for this grade, how many customers are there? The 1 as well as the 2. This is what the expected output for third query, that is count the customers with grades with above Bangalore's average. So now according to that we got the output. So now next interesting query is find the name and numbers of all salesmen who had more than one customer. I repeat, find the name and numbers of all the customers, all the salesmen who had more than one customer. This query is very simple. This query is very simple. First, I want to display the two tables information so that you can get an idea. The salesman and customer. Okay, these are the salesman ID and these are the customer ID. They want to display the salesman's informations who are having the customers more than one. You can see salesman ID 1000 is having the two customer, salesman ID 2000 is having the two customer, salesman ID 3000 is having only one customer. That means in our expected output we should have this particular information, that is salesman ID 1000 is having two customers, salesman ID 2000 is having the two customers. And this is not actually required, because the find the name and numbers, that means salesman's information who had more than one customer. That means here the two salesmen, the 1000 as well as 2000, they are having the two customers. So now again we will see this information. First I will again execute the part by part query. Why I am showing this part by part query is so that you people can get some basic idea. So now here I am executing the query. This will display some part of the information so that, okay, so here you can see salesman name and count, number of customers in every salesman. So 1000 is having the 2, 2000 is having the 2, and 3000 is having the 1. This is what just now I had explained. For that I have written select. After that we are having the s dot salesman id name count c dot customer id from. Here you can see for every table I'm giving alternative names. For the salesman table, instead of using every time salesman dot salesman id and c dot customer id, customer dot customer id, instead of that we are using the shorthand notations for the tables. For the salesman I'm using yes, for customer I'm using the c. You can give any alternative letters to identify the tables. These are just an alternative names for the tables. So that why we are using this, because when two or more tables are having the same column names, that time it is very difficult for the this particular query to understand from which table we are referring. That's why we are supposed to mention the table name first, then followed by column name, because you can see salesman id is present in the salesman table as well as the customer table. So if we do not specify this yes, that time while executing the query, so engine will get confused from which particular table this salesman ID is we are referring, whether this customer or salesman. That's why we need to clearly mention the table name. And instead of using complete table name, we are using the shorthand notation. That's why I'm displaying the salesman ID information, name of the salesman, and count how many customers are there in that particular respective salesman. And so this is what the output we are able to get. If we, because when we group the records according to the salesman id, that time we get to know how many customers are there under that particular salesman. That's why we are grouping the records in this particular customer table according to the salesman id and name. Okay, and as we are referring the two tables information, this condition is mandatory here. So customer and salesman, both table are having the common field as salesman id, and in that when the common field is there, that common field should be primary key in one table and foreign key in the other table. This condition is mandatory first, then this is the grouping. We are grouping the records just to understand how many customers are there. Now here the condition is what? Condition is who had more than one customer. So that's why for this group we are applying the condition in this case. Again I am showing that result here. Again I am showing the result. Again for this only we are adding the condition, one more additional condition, that is here up to this the query is same. Okay, I'm just adding for this group the condition is having clause is used to apply the condition for the group. So the count should be count of customer at should be greater than 1. That's why here in the previous case we have not applied this particular condition, that is having. That's why we have got the 1000, 2000 as well as the 3000, 2 to 1. But when we apply this particular condition, that is the count of the customers should be greater than 1. That's why those two records only displayed. This record has not displayed. This is what an expected output for this particular query. Okay, so now this is the second query. Now again move ahead with the third query. Third query is what? List all salesmen. Okay, we need to again list the salesman information and indicate those who have and do not have the customers in their respective cities or in their cities. Here they explicitly mentioned usage of union operator. In the relational algebra we are having the various operations: union, intersection, and cross product, set difference, like that. This is the relational algebra operation basically from the set theory. Okay, so first we need to understand, list all the salesmen and indicate those who have, first one, the customers in their respective cities, and next we will see do not have. First we look at have and do not have. Okay, so that means here the question is we need to check the salesman and customers who are there in the same city, first part, and in the second case who are not there in the same city. Again I will show the part by part query. Okay, so this is the first part of the query. In this first part of the query I will show you. Okay, first I will display select star from salesman, and again select star from customer. Okay, so first we need to check salesman and customer both should be there in the same city. In the first case, we need to look into that particular case where salesman and customers both are going to be in the same city. Here you can see salesman ID 1000 John is in the Bangalore and customer ID 10 Preeti Bangalore. That means these two are in the same city. Okay, according to our first case, this information needs to be displayed because salesman and customer both are in the same city. Okay, so again we need to look into the same cases with the other case. Okay, so now again I will show you the part of the query as I told you so that you can get to know the idea. Okay, so this is the simple query. Here you can see I'm going to display the information about salesman ID and name of the salesman, and again I'm going to display the customer name and salesman city and customer city. I want to display this all information so that we can get to know which salesman and which customers are going to be there in the same city. Okay, so as we are referring the two tables here, again the condition is salesman and customer C. So these two tables we are referring, that's why we are taking the first condition as salesman ID, as it is the common field in both tables. So we are taking this as the first condition. Second case is salesman city and customer city, both should be same. Okay, when salesman city and customer city are same, we want to display only that information. Again, when we look at this, as I told you, 1000, that is this is the salesman and Preeti is the customer, and these two are belonging to the same city, that is the Bangalore. That's why salesman city and customer city both are same. So you can see the output. So here we are having salesman and 1000 and 2000. These two, John and Ravi, and these two are the respective customers, and they are there in the same city. That's why we are getting the output like this. And it's opposite of this. Opposite of this means who do not have the customers and salesmen in the same city. It's opposite. That means customer and salesman both should be in different cities. Okay, again I'm making a slight change there. Again I'm going to make the query is almost the same, but a slight change. What I'm going to do is, here you can see here s dot city equal to c dot city. That means customer and the salesman both should be there in the same city. Here I'm using the not operator. In the second case I'm using the not operator to indicate that customer and salesman should be in different cities. Again, for this output what we're getting, see here you can see the John is there in the Bangalore city and Vivek is there in the Mangalore city. That means it is displaying the information in which salesman and customer both are in different cities. In the first case, both are there in the same city. In the second case, both are there in the different cities. Okay, we need to combine these two union operation. According to the set theory, what it says, union operation. Okay, if the two sets are there, that means when we take a union operation of those two sets, that means we are going to get the output. In the output, we are going to include the elements from both set. So that's why in our output we should have these two records and these three records, so that when we apply the union operation between these two cases, we should get output as the 5 records. That is what they expected in this particular query. So here this is the union operation. By combining these two, we are supposed to get output as the 5 records. So now I will show you the output. In the output we are supposed to get the 5 records. That is what the union operation. Now here you can see all 5 records have been included. First case, salesman and customer both are in the same city. In the second case, salesman and customers are in the different city. So now by combining these two, we are getting the output totally 5 records in the same city as well as in the different cities. This is what the required output for the third query. Okay, so now again going to the next one. In this particular case, we need to create a view. We need to create a view that finds the salesman who has the customer. We need to create a view that finds the salesman who has the customer with the highest order of the day. Okay, you just forget about this view. First you need to understand the query. Find the salesman who has the customer with the highest order of the day. Again, in this case also we are supposed to display the information about the salesman only. Okay, here also we need to display the information about the salesman. In almost all the cases they are expecting, they want to display the salesman information only with the condition as the customer. Okay, so here they want to display the salesman information who has the customer with the highest order of the day. Okay, for every day we are going to have the orders. Okay, in that particular order, which customer is having the highest the order amount, and that particular salesman information we want to display. Again, to get the information, to get the idea about this, again we need the information about the all three tables, so that you can get to know the idea about this particular query. Okay, so again I'm going to show you the information about the three tables: salesman, customer, then third table is the orders. Okay, here you can see fourth day, that means 4th May 2017, we are having the order purchase amount as 5,000. And again in the 4th of the same day, that is the 4th May 2017, we are having the order amount as 5,550. Okay, so that means among these two, this is also the same date and this is also the same date. Among these two, which order is having the more amount? That is this one. Okay, so for this case we are having the customer ID is 10, and for this case we are having the customer ID is 12. Okay, and when by taking these two cases, by taking these two cases, which is having the maximum purchase amount of that particular day, that is 5,550. Okay, so this is the customer. For this customer, who is the salesman? That is 2,000. That means in the output we are supposed to display the information about the salesman with the ID 2000. In the remaining all cases, you just observe all are having the independent order ID. That means for the 17th January only one order is there, for 24th February only one order is there, for 13th April one order is there, and 12th March we are having the one order. That means these 3 dates we are having only one order. That's why, and in that particular case all are having the highest order amount. But only for this 4th May 2017, for the same day we are having the two orders, and among these two orders we are supposed to take 5,550 as the maximum case. Only we are supposed to display out of these two, we want to display only one order. So among these 6 records, we are supposed to display only 5 records information. That is 5 salesman's information: 1,000, 2,000, 3,000, 2,000, and 2,000, because these all are unique with the highest purchase amount. This is what an expected output for this case. Again, I will show you. So the output of this particular case. Now, when we execute this, again when we execute this, okay, now here you can see 17th January 2017 450. So here the salesman is John and name of the salesman is salesman is 1000, name of the salesman is John. In the same way, here I have taken the shown for the 4th May 1000, and again for 4th May 2000. Among these two, see here you can see for the 4th May we are getting only one output. Okay, so this is the query for that particular case. So as we are referring the two tables, salesman and orders information, according to that this this query has been designed, and we got the output. This is an output for the query. Here we are having one more concept, that is the view. View is a virtual table. Okay, view is the virtual table. Why virtual table? Every time if I want to see the output of this, every time if I want to see the output of this, I supposed to remember this entire query. Okay, so every time I need to remember this query, I need to type this query, then only I'm able to get the output of this. Okay, instead of remembering this query every time to see the output, they had introduced the concept of virtual table. View is nothing but virtual table. That means the output of this information we are going to place it in a virtual table, and that virtual table is also having the name, and we are going to create that table. There's a virtual table with the information like this. To create the virtual table, to create the virtual table, I'm just showing you how virtual tables are going to be created. Okay, so create view. View is nothing but virtual table. Again, this virtual table is also having the name. I'm giving the name for this virtual table as Elite Salesman as. Okay, so what this particular virtual table should store now, whatever the query I have shown here, this query in output I want to store in that particular virtual table. So now again, I'm executing this and copy and paste. Okay, so now here you can see, here we are not getting any output, so we people are surprised. That means where that output is. Now again, if I want to see the output, now just now I have created the virtual table by the name Elite Salesman. So now if I want to see the output of this, as it is stored in the table by the name Elite Salesman, Elite Salesman. So now, just like a normal table, select star from Elite's Salesman, because the output of this query has been dumped into the virtual table by the name Elite Salesman. Now if I want to see the output of this query every time, no need to remember this query. We simply execute this query so that we can get the output of that query. That's why this is a demonstration for how the virtual tables are going to be used. That's why this is the create view. Okay, and the last concept is, last query is demonstrate the delete operation by removing the salesman with ID 1000. All his orders must also be deleted. Okay, so the last query is about delete operation. So before I show the delete operation, I want to display all tables content first. Select star from salesman, then second table is the customer. Select customer. Third table is orders. Okay, so now here you can see salesman id information is referred in the customer table, and it is also referred in the orders table. So now here, in while creating the tables, we had mentioned on delete set null, we had mentioned on delete cascade. These two constraints are specified exclusively for foreign keys. Okay, so now we will see what actually on delete set null does, what actually on delete cascade it does. On delete cascade I have shown already demonstration in my previous video. Now today we will see on delete cascade. Now I'm going to delete a record from only salesman table. Delete from salesman. The question is what, with the salesman id as salesman id as 1000. I want to delete the records. Here I'm just deleting the records from the table salesman. I'm not deleting the record from customer as well orders. Okay, so as during the creation of the table we had specified for the foreign key on delete set null and on delete cascade. Now we will see what actually those constant does. Now I'm just deleting the records. Here you can see the records have been deleted. So now once the record has been deleted, now again we will see the tables one by one. Here the in the salesman table, record with the salesman ID 1000 has been deleted. Now I will go ahead the customer table. Here you can see the importance of on delete set null. Okay, so that means this 1000 salesman ID now has been replaced with the null value. That is what the meaning of on delete set null. So that means in the child table that record has been set to null. Again we will go with the orders table. Again in the orders table that record has been deleted. That means on delete cascade it will delete the records in the respective child tables. So now this is what the case of the second lab assignment order database. Okay, for any queries, so you can contact me. So thank you.